How about now? I don't know why that didn't work. Okay. Well, let's try that again. See, it's like a silent movie. You have to imagine the sound. That's the idea. I was going for something different today. I figured we do these live broadcasts so frequently, and you know, you guys are just so spoiled with actual audio and hearing my voice that you know, I figured we'd try it as like a silent movie, and you could just dub in your own audio. Please don't do that. Oh gosh. All right. Well, we're off to a great start. This is a fantastic start here. So, let's back it up. Let's back up the train. And, I don't know why that's a train sound. I need like a train button. And let's try the intro. We'll try the intro one more time. We're here for Rocket Lab. That's what we're here for. The Rocket Lab Electron. It's a little something different. We haven't had one of these in a while. At least not here on this channel. They do them, but, not, I think we missed the last one. But we're back again for it. I love Rocket Lab. Love everything about Rocket Lab. They're doing some, they're working towards some reusability. We won't have any reusability today. No recovery or anything like that. But we're going to watch and see what's going on with them today. They are launching out of New Zealand, but they are a U.S. launch company. We'll kind of take a look and see some of the maps and all the usual stuff that we usually see here. We'll dive into that. A couple people talking about SN11 for Starship. We'll definitely get to that at some point. We probably won't talk too much about that today because that's not what we're here for. But Starship did have a static fire today. A couple people talking about... I didn't know... I was just kind of loosely paying attention to the static fire, but some people are talking about broken heat tiles on Starship SN11. I don't know anything about that. I haven't really paid much attention today. I had to work today, so I wasn't really paying attention, but I'll definitely check that out, and we'll see. Dusty over on Facebook says your auto captions don't work without your voice. I imagine that would be a problem. It seems like a prerequisite for auto captioning. Let's see what else everybody's doing. I saw where everybody was from. I saw a couple super chats come in. Probably should acknowledge those. I saw Neko threw in a super chat. Managard, one of our longtime Patreon members, also became a YouTube channel member. Thanks, Managard. Thanks for your support. Thanks, Neko, for the super chat. And Star Andrea 22, another name that I recognize there. Thanks, Star Andrea. Appreciate the super chat there. Thank you very much. What are they launching? We're going to get into that here in just a second, but I figured I'd jump through. I always say I'm going to look through the comments, but then I always miss some of them. So we'll grab a couple of them before we dive too far into it. Glenn says, you can say launch as many times as you want today because this is not an SLS hot fire. This actually is a launch. So yeah, I will say that many times. Just not the Jim Bridenstine quote.
American astronauts on American rockets from American soil.
Where's Time Waster? I think that drives Time Waster nuts every time we play.
American astronauts on American rockets from American soil.
All right, let's get... so Rocket Lab is probably going to come... They usually go live a lot sooner than SpaceX does. Are they live yet? Oh, yes, they are live, but there's nothing happening. So we'll jump into them. We'll listen to them here in a minute, but... Thank you, says Time Waster. He loves it.
American astronauts on American rockets from American soil.
So let's jump in. We'll take a little preview of what's happening today, what we're launching, what's going down. So this is the Māhia Peninsula over in New Zealand here. So it is a U.S. launch company, but they are launching in New Zealand. So here's New Zealand off the coast of Australia, in case you're not familiar here. A little geography lesson maybe. But the Māhia Peninsula here, probably the most gorgeous launch site in the world. What just happened? Okay, now we're in Canada. All right, cool. Let's go over here. Down to the Māhia Peninsula, right here. The best looking launch site in the world. Gorgeous views from there, right here. And the Rocket Lab launch facility is right at the very point of the peninsula there. Winds are looking okay. We got 7 mile per hour ground level winds. We'll talk about our weather here. Upper level winds, not too bad, 17 miles per hour. Somebody help me out, convert that to metric for all of our non-US friends, because the US didn't teach me metric system, so I only know miles per hour. But So they're launching from there, and we'll look at trajectory here as well. There's not really too many concerns for weather today. It's actually looking pretty good from what I can see, but obviously I'm not the rocket launching weather expert. But trajectory is heading to the south, and it's almost a retrograde type orbit because it is a polar orbit, but it is inclined. It'll be inclined 45 degrees in the end, is what I saw. But the track from this is from flightclub.io. Looks a lot closer to a polar orbit here, according to flightclub.io. But they're reporting it as a 45-degree inclination for their actual satellites here. So, and there's a few satellites that are going on board. We'll dive through and take a look. Rocket Lab, the Electron, much smaller rocket here than, say, like SpaceX, the Delta IV, or anything like that. This is designed for small CubeSats, microsats, things like that. So this is not really a direct competitor to like SpaceX, although SpaceX is kind of dabbling in the CubeSat, small sat industry a little bit with Starlink. They're trying to get some ride shares to ride along with Starlink. But Rocket Lab is a dedicated small sat launch provider. Small sats, CubeSats, things like that. You're not going to see them launching big, giant SUV size payloads, not on the Electron at least. Maybe on the Neutron, their new rocket that they just announced. But yeah, not on this one. This was a much smaller launch here. So we do have a 1 hour launch window today, but they're targeting, the launch window goes from, what's the UTC? 2220 to 2320 UTC, which is in about, so the window opens in about 10 minutes, but they're targeting launch in 20 minutes. So 10 minutes into the launch window. So they will have 50 minutes in the window to actually pull this launch off. There's 7 satellites on board here today, and again, CubeSats, very small sats. A couple of them are demonstration missions. You can see a lot of technology demonstrations with these small CubeSats, little like proof of concept things. So you've got Photon, the Rocket Lab's Photon. You've got BlackSky Global Series. You've got Centauri 3, Myriota 7, Myriota 7. I don't know how you say that. Veery Hatchling, M2, Gunsmoke J are the payloads that are on board here today. And there's a couple, I forget which one's which, but a couple of, or we got Earth observation microsatellites here. We've got, and we'll listen into Rocket, where's my Rocket Lab feed? Once they actually come up, we'll listen into them. I'll let them explain that a little bit better about each particular satellite. What else? One of them's a technology demonstration for, where is it? Which one is it? This one here is a weather satellite. That's the Veery Hatchling here. I don't remember which one, the one that I wanted to talk about. This one here, I think. This one, the U.S. Army, the Gunsmoke J, that's an experimental CubeSat, and a test technologies that support development of new capabilities for the U.S. Army. So, not a whole ton of detail in the press kit itself, but there's a bunch of different satellites that are going up here today on this. And again, very, very small satellites, not huge ones. But let's listen in. We're going to pull them up because they're about to go live. We'll listen in. We got Rocket Lab music. Yeah, we'll let them go through their intro here. Well, you can take a look at it. What does the inclination mean? Says Jacob. So the inclination is generally the highest latitude that the satellite would reach, or the lowest latitude. So if it's a 45-degree inclination, that means that the satellite will go up to 45 degrees latitude before it starts heading south again, and then it will reach 45 degrees south latitude. And that's based on orbital mechanics here, so it's really just going in a straight line. Like, the satellite's not turning and going south. It's just going in a straight line, but it's inclined. The orbit is inclined, so it's not directly east-west. It's not directly north-south. It's at an inclined orbit. And so as the Earth rotates underneath it, it can never reach higher than 45 degrees inclination. Hope that makes sense for you. I can show that to you maybe after the actual launch here.
for the Electron's 3D printed Rutherford engines, and I am thrilled to be joining you for another Electron launch. Today's mission is a special one, as it will tip us past 100 satellites deployed for our incredible customers. With 6 satellites on board, plus our very own Photon spacecraft, today's deployment sequence will take place in 2 parts. First, Electron's Photon spacecraft will act as a kick stage to deploy 5 satellites to a 550-kilometer circular orbit. Then, we'll use Photon's Curie engine to lower the spacecraft's orbit to 450 kilometers for the final customer deployment. From there, Photon will remain on orbit to build flight heritage ahead of an exciting mission to the moon for NASA this year. But more on that later. We're proud to be welcoming some repeat customers onto Electron again for this mission, and we're also excited to work with some new ones.
One of the repeat smallsat operators and the first payload manifested for this launch is Earth observation company BlackSky. Their Gen 2 spacecraft will become part of a constellation to deliver real-time global monitoring from space for public and private organisations. We've also got 3 Australian small satellite operators on board Electron today. The first is from Fleet Space in South Australia, who first flew on Electron in 2018 on our It's Business Time mission. Fleet Space are building out an Internet of Things constellation in low Earth orbit, which their Centauri 3 6U nanosat on this mission will soon join. This satellite will also support the 2023 Seven Sisters mission out of Australia that will investigate new resource exploration techniques for Earth, the Moon and Mars in support of NASA's Artemis program.
The next Australian spacecraft is the Myriota 7 satellite, another Internet of Things smallsat. Myriota's mission is to provide access to data from anywhere on Earth for those working in the utilities, transport, and logistics space. The third Australian satellite is the M2 satellite built by the University of New South Wales Canberra Space. Working with the Royal Australian Air Force for this mission, M2 will bring together technologies that cover Earth and marine observation, quantum computing, artificial intelligence, and communications.
Here's M2
Other
right
satellites
there.
on this mission include the very hatchling 1U CubeSat from CareWeather, a company focused on saving lives through better forecasting of Earth's extreme weather.
And last but not least, we have an experimental CubeSat from the U.S. Army's Space and Missile Defense Command, or SMDC, flying on Electron today.
Now, there's also one more payload on this mission that we're very excited to tell you about. We have a Rocket Lab Photon spacecraft on board. This will be the second of our in-house built customizable satellites launched on Electron, and we've named this one Pathstone. Like Photon First Light before it, Pathstone will first perform its usual kick stage responsibilities of deploying our customer satellites, before making the switch to Photon mode and carrying on with its own mission in low Earth orbit. Here to tell us more about the Photon on this mission is Jane McNichol in our Rocket Lab Long Beach headquarters. It's great to see you, Jane.
So this is actually built by Rocket Lab themselves.
Thanks, Muriel. My name is Jane, and I'm a mission integration engineer here at Rocket Lab.
We want the other
I'm
view.
excited to be joining
The other
you
one.
from our
Go
Mission
the other.
Operations Center inside our headquarters in Long Beach, California. It's from our
There we go.
production complex
Nope.
here on the
That's
West
not
Coast,
it either.
where our team produces more than 130 Rutherford engines and guidance and avionics hardware for our Electron rocket every year. It's also where our team builds our Photon spacecraft and operates them once on orbit from some of these consoles in the operations center that you can see behind me. Photon is pretty unique in that we can first use it as a kick stage from which to deploy our customer satellites. Then we can switch it into spacecraft mode to stay on orbit and complete secondary missions. Essentially, it performs 2 functions. First, as part of the launch vehicle, then second, on its own as a standalone spacecraft. After Photon has deployed all customer payloads on today's mission, it will remain on orbit to build flight heritage for hardware and subsystems ahead of our mission to the moon for NASA later this year. The Photon Pathstone launching today has several updated subsystems from Photon First Light, launched in August 2020. The primary technical and risk reductions and goals for Photon Pathstone will be to advance test the flight computer, test GNC algorithms and flight software updates, conduct radio and Doppler ranging testing, and also validate our own in-house built solar panels. All that testing will be used to inform our most complex spacecraft mission yet, the Capstone mission, which will see Rocket Lab place a satellite into lunar orbit for NASA. Capstone will serve as a precursor for Gateway, a moon orbiting outpost that is part of the Artemis program to return humans to the lunar surface. Today's launch is another step towards this thrilling mission that our team can't wait to see launched later this year. They're counting down the minutes to liftoff, and I'm eager to go join them, so I'm going to hand it back to you in Mission Control.
Thanks, Jane. Right now, we're at about T-minus 12 minutes and coming up to the go-no-go poll run by our launch director with our launch operators. That's due to begin shortly, so let's listen in now to Mission Control.
They changed up my timeline on me. They were.
Com checks.
See if we can change that. Update that real quick. I don't know why I've had that at 18 minutes. Put that up here for 12 minutes instead. So this will be the go, no go polling. One thing that...
All right, and all stations...
we'll listen into this first.
At this time, we are proceeding with the go, no go sequence, number 43. Stage, are you go?
Stages go.
Avionics.
Avionics is go.
Avionics up.
Avionics up is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Met is go.
MM.
MM is go.
LDSUP.
LDSUP is go.
And exec.
Exec is go.
Stations LD on mission. The go no go sequence is now complete. We are currently T-minus 11 minutes 17 seconds and counting. I can confirm we are go for terminal count at T-minus 10 minutes. Be advised from this time onwards, the 3-word hold procedure is in effect.
All right, things are looking good for pretty much on time,
There
right
we
at
go.
the beginning
That was
of the window.
green light we needed to launch, and we are go as we approach T-minus 10 minutes and 54 seconds until liftoff.
Now, when it comes to missions beyond Earth's orbit, there's still a lot to learn about how humanity will further explore our solar system. But there's one particular orbit near our moon that will be a great place to start. As Jane mentioned, Electron and Photon will launch to the moon for NASA later this year in support of the Artemis program. Photon will complete a series of orbit raises using its Hypercurie engine before deploying NASA's Capstone CubeSat toward its intended near rectilinear halo orbit, or NRHO, around the moon. There's a bit more about this exciting mission launching later this year.
Oh, all right. We got to turn that down because we can't play their music. I don't have the rights to play their music, so we'll just keep an eye on it and watch what's happening with some of the footage here. We got exactly 10 minutes on the clock coming down. It looks like things are going to be okay. Steve Robinson over on Facebook says play it loud. Yeah, one thing to keep an eye on when Rocket Lab when the Electron ignites its engines. Very, very powerful. I love the actual ignition process. Like when they get down to it, 3, 2, it's just a big, like it's a real hard hit. I absolutely love that. So what they're talking about now, the Capstone project is in support of the Artemis program here. So they're trying to get, this is going to be Rocket Lab providing payloads in lunar orbit. So moving beyond just small CubeSats and small sats that are in low Earth orbits, they're actually trying to move out to lunar orbit. Peter Beck has talked about he wants to send stuff to interplanetary missions to like explore Venus and things like that. So Rocket Lab is kind of a nice up-and-coming company here that is expanding out. I mean, originally he said that they were not going to do anything beyond Electron. But now we've got, I like this animation here of the actual, the orbital change there. So you can see, a lot of people think when you're traveling from Earth to the moon or interplanetary or things like that, that it's just a straight line, like you're driving in a car, like we just point at the moon and we'll go there. But they forget that you gotta orbit, and your orbit's you gotta make changes to your orbit in order to actually get to the moon. So I like that there. I think they still got some music playing. Probably could we'll turn on their closed captions, then you can at least see what they're saying. Let's see. Let me grab a couple comments before they come back. It's so different in Europe. This is New Zealand. This is not Europe. So they're launching. This is the Māhia Peninsula off of the coast of New Zealand here, down in this region here. So we're not launching from Europe, launching from New Zealand. Maybe you were talking about something else, but I did see a couple people ask where it's launching from. This is New Zealand. And don't forget, Rocket Lab is a U.S. company. but they fly out of New Zealand. They also have a launch pad that's going to be at Wallops Island in Virginia that is not online yet, but it's coming online very soon. All right, let's turn them back up now.
Enable FTS for flight.
Sync sequence 48.
FTS is enabled. That's the flight termination system. We're at 7 minutes here. Now we'll get strongback retract coming up right at about 7 minutes. They start the retract of the strongback. That's
AFTS is green and enabled for flight.
There we go. AFTS green. It is an automated flight termination system.
Thank you, avionics.
There we go. We should get the strong. Are we going to see the strongback going back?
Earlier this month, we made a pretty big announcement. How big? 40 meters big, to be
Neutron.
precise. We confirmed that a new, larger vehicle, Neutron, will be joining the Rocket Lab family.
The medium-lift Neutron rocket will be a two-stage vehicle that stands 40 metres or 131 feet tall, with a 4.5-metre fairing diameter and a lift capacity of up to 8,000 kilograms to low Earth orbit.
Neutron's 8-ton lift capacity makes it the ideal launch vehicle to deploy satellites into batches to specific orbital planes, creating a more targeted approach to building out mega constellations. But just like Electron, Neutron is designed to lift payloads beyond low Earth orbit too. With a payload capacity of 2,000 kilograms to the Moon and 1,500 kilograms to Mars and Venus, Neutron will be able to enable important science missions beyond our own planet. Neutron will initially be designed for satellite payloads, but will also be capable of International Space Station resupply and even human space flight missions, which is very exciting.
We'll be launching Neutron from Virginia's Mid-Atlantic Regional Spaceport, located at the NASA Wallops Flight Facility, where Rocket Lab's Launch Complex 2 is located. Using this existing launch pad and integration infrastructure at Mars, that means we can accelerate the timeline to first launch, which, in true Rocket Lab style, is sooner rather than later, expected in 2024. And I think it's safe to say Peter won't be making any promises on eating a hat anymore, because that did not look tasty.
No, it didn't. But for this mission, we won't have a live view from Electron once the second and third stages separate, but we will be staying on air through the coast phase as the kick stage makes its initial pass around Earth to circularize its trajectory. About 10 minutes into this initial coast phase, our founder and CEO, Peter Beck, will be joining us for a Q&A session on Neutron, so be sure to stick around.
Interesting.
After that,
right.
We'll come back to you with the simulation and confirmation of payload deployment, so make sure to stay with us.
It's now T-minus 4 minutes and 42 seconds to launch. Electron and its payload is healthy on the pad, and the weather is looking clear for an on-time liftoff. Let's hand over now to Mission Control to listen in to the operators in these final seconds to launch.
So usually Rocket Lab doesn't stay live through payload deployment. A lot of times they cut off the broadcast early, but they're not going to do that today, so that's kind of good news. We can hear the sirens at the facility there. I was going to say something. Oh, the rocket itself is, you can see it. It looks like a black and white rocket. It is not.
GCS is disabled. Pad auto sequence is armed. Pad is ready for launch.
Copy GC, thank you.
It is not a black and white rocket. It is a black rocket. The white there is actually ice forming on the outside of the rocket. So that's basically where the super chilled liquid oxygen is on the outside of the rocket there. That's you get that warm, humid air on the outside, especially being seaside like that, touching that cold surface of the rocket and basically forming ice on the outside. So it's not a black and white rocket. It's just it's a solid black Electron rocket there, but you can see exactly where the liquid oxygen tanks are, which is pretty cool. Think SpaceX and Rocket Lab will ever work together? I don't know about that. I mean, they're not really in the same space, really. I mean, yeah, they are launching rocket. Well, although with Neutron coming on board, they will be in a little bit closer. But yeah, I mean, I don't really see them working together so much.
All stations, this is LD on mission. From now on, there should be no red flags on your critical LCCs. Beacon LD mission.
LD beacon.
Please confirm flight computer as goes green.
Confirmed.
And please lock the auto sequence and confirm.
Locked.
station's LD on mission. We go for auto sequence start at T-minus 2 minutes. And at this time, I can confirm LD is go for launch.
Here we go. That's a good sign. That's a good sign there. Launch director, go for launch. Coming down to the final 2.5 minutes. So we should have views, at least initial views, after launch. A lot of times they lose the actual view, and I think he did say that they're not going to have camera views after the second separation event. But they're going to stay
UVs are on internal power.
Stay live through the coast phase.
All stage power is disabled. The vehicle is on internal power.
Hey, Adam Farmer, thanks for the super chat. Says, woo, more rockets, more zooms. Big zoomy, no whammy, let's go. I love it. Here we go, 1.5 minutes. Watch for that right as we come down to it, the actual ignition itself, like super powerful. It's just... That's my favorite part about actually watching Rocket Lab launches for the Electron.
Box load is complete. System is in recirculation.
No, there is no recovery for the first stage yet. They did attempt that.
Stage 1 anti-geysering is disabled.
They've kind of dabbled in that a little bit. They're not ready to continue more on that, but we will see more into recovery stuff on future missions. Where they're just not there yet. Anti-geysering, which is what they just said was disabled, that kind of stirs.
Stage 1 and Stage 2 are pressed for flight.
It stirs the liquid oxygen tank a bit, so it doesn't. So you don't get pockets of
High flow engine purge is enabled.
Pockets of warm temperatures in there. Here we go.
Water deluge is activated.
Water suppression system. Thanks, Star Andrea 22. Appreciate it. Here we go. Get ready. Get ready for the. I'm telling you, like 2 seconds at ignition. Where is it? 3 seconds? 2 seconds. 2 seconds.
Ten, 9, 8, 7, 6, 5, 4, 3, 2.
I told you that was awesome.
They really do go up so fast with a beautiful liftoff of Electron from the pad at Launch Complex 1. We're now T plus 40 seconds into the mission and approaching max Q, or maximum aerodynamic pressure, at the 1:09 mark. Max Q is the moment during launch when Electron experiences the highest amount of mechanical stress from the dynamic pressure, which is a function of its velocity and altitude. We'll be coming up on max Q in just a few seconds.
Here we go, max Q coming up at 1 minute and 12 seconds. Maximum dynamic pressure on the vehicle.
Vehicle past maximum dynamic pressure.
There it is. So they've now passed through max Q.
And there's the call that we've successfully cleared max Q. All is looking good with our trajectory, and Electron is performing nominally.
Looks like some of the stickers are peeling off right there. You can see him kind of flapping and vibrating there. Those are I believe those are just the decals that are just peeling off the side of the rocket.
Stage 1 guidance is nominal.
Getting a lot of movement, seems like.
US chatting
Geez,
station.
more decals peeling off here.
We're quickly approaching the next set of milestones in this mission. First up will be main engine cutoff of the 9 Rutherford engines on Electron's first stage. This is when the engines throttle down before the vehicle separates into sections, or what we call stages. Following that, the sole vacuum optimized Rutherford engine on that second stage will fire up to continue the journey to low Earth orbit. We're a few seconds away from those events, and those calls will come in quick succession. So we're going to cross back to mission control now.
Here we go, Miko and separation.
Successful.
There we go. Look at it. Just yeet
Stage
out of
three
there.
ignition
See ya. Love it. You can see, look how fast it separates from that first stage.
And you've seen it on your screen there. We have had a successful MECO, first and second stage separation and ignition of the Rutherford engine on Electron's second stage. Coming up in a few seconds, Electron's fairing will separate. The fairing is the casing at the top of the rocket that protects the satellites as they travel through Earth's atmosphere.
Fairing jettison succeeded.
There's the fairing.
And there they go. The fairing has cleanly separated and fallen away from Electron, which is continuing on a nominal trajectory.
Stage 2 guidance is nominal.
So now we're coming up on battery hot swap here. So the turbo pumps, I guess they're not turbo pumps, they're electric pumps that feed the fuel into the combustion chamber for the engine. They are electric battery powered pumps. And there's 3 batteries on board. As the first 2 are depleted, they're jettisoned to get rid of that extra weight. And then they switch over, they do a hot swap.
Electron's trajectory continues, as you'll often hear us say, nominally, with a current speed of just under 10,000 kilometers per hour and an altitude of about 165 kilometers, and we are now at about 4 minutes into the mission.
So they're going to switch over to that third battery there. They switch power to it, and that happens, usually it's just over 6 minutes. Today it's just under 6 minutes, about 5 minutes and 45 seconds there. But look at that. That's a pretty gorgeous view right there. They went through the clouds during the actual launch itself, but that's fantastic. Like I just want a high-res picture of
Some
that.
absolutely stunning views of Earth from Electron's Stage 2 camera. The journey toward low Earth orbit is going smoothly so far, and we're about a minute away from battery hot swap.
Battery hot swap coming up. Adam Farmer, another super chat. I saw your other one, Adam Farmer. Adam said he's going to get in trouble with his wife for all the super chats. Thank you, Adam. Don't get the wife mad at you. All right, so that battery hot swap, we're about 45 seconds away
Stage
from...
2 propulsion remains nominal.
High voltage battery discharge nominal. Approaching hot swap.
As we mentioned before, in the next few moments we'll be coming up to the battery hot swap, a maneuver that's very specific to the Electron rocket as the only launch vehicle flying with battery-powered electric pumps feeding our engines. When the first set of batteries are depleted during launch, we switch to a fresh one to power the engine for the rest of the mission. Sometimes you can see those battery packs fall away after the event, so let's keep an eye on the live feed from Electron and listen into mission control for the call.
Well, 10 seconds away. Just under 10 seconds here. Right here. Oh,
Battery jettison
there they
confirmed.
go. Wow, that was actually a really good view of that.
Propulsion remains nominal.
And there we go, that's confirmation that the battery hot swap was performed successfully on Electron, and propulsion continues to look good for the rocket's second stage Rutherford engine. We're just a few minutes away from orbital insertion and kick stage separation on this mission. Electron is currently travelling at over 15,000 kilometres an hour and at an altitude of 276 kilometres above us.
That was probably the best view of the battery hot swap that I can recall seeing before.
Current altitude is 280 kilometers, speed 4.9 kilometers per second.
Who's clapping? Everybody's just standing. Yeah, usually there's probably like a gallery viewing of the rest of the staff, like staff that's not necessarily in mission control itself. A lot of times, like at SpaceX, they have...
If you're just joining us, we have had a successful liftoff of our They Go Up So Fast mission. About 2.5 minutes into flight, we had main engine cutoff, stage separation, and stage 2 ignition. We're coming up on separation of the kick stage at around T plus 9 minutes.
So now we're waiting on that second stage cutoff here.
The view on your screen is Electron's second stage Rutherford engine. This engine is the same as the 9 engines that lift Electron off the pad, but with an extended engine nozzle for optimized performance in the vacuum of space. We are looking good for SECO or second engine cutoff shortly.
Does this land back today? No. So the Rocket Lab isn't. The first stage will come back, likely break up in the atmosphere. They're not doing recovery yet. They've dabbled with some experimental recoveries. They're going to get there. They're not actually going to land them propulsively like SpaceX does.
Stage 2 burnout detect mode.
Shortly, Electron will shut down the Stage 2 Rutherford engine to allow for a clean separation of the kick stage. That will place the kick stage in an elliptical orbit around the Earth for a coasting period of around 40 minutes or so. That event is coming up shortly, so we're going to switch back to mission control to await the confirmation.
So we should have that second stage shut down
Stage
here.
2 guidance is in terminal. 10 seconds remaining.
Waiting on shutdown. There it is.
SECO confirmed.
Stage 2 separation confirmed. Transfer over to confirmed.
There you go. Now you can see the gallery back there. There was some people that were asking about where the clapping's coming from.
Fantastic news that the Rutherford engine on the second stage has successfully shut down as planned, and the kick stage has cleanly separated.
The kick stage is now going into its coasting phase for about 40 minutes or so while we wait for the circularization burn from our innovative Curie engine. In the meantime, we're going to take a small break, and you can join us back here in about 10 minutes as we're joined by Rocket Lab founder and CEO Peter Beck to answer some questions about our Neutron program. We'll be right back.
All right, cool. Well, there we go. So this is a little bit different from what we normally see from Rocket Lab. So now we can actually see. Oh, so this is, yeah, maybe Flight Club has the trajectory wrong. I was trying to figure out, because this, so here's the Flight Club trajectory that we had. I was like, how is that going to turn out to be a 45-degree inclination? So that's the wrong, that's not correct. We refresh that. Is it still up to date? No, it's going that direction. All right, so maybe Flight Club didn't update their trajectory yet, but here we go. So this is a little bit different. This is the trajectory that we're on. That makes a lot more sense because now we're going to actually have people that were asking what the inclination means. Basically, you're going to hit 45 degrees south and 45 degrees north, and that's as far as you'll make it north or south. So when you see a 45 degree inclination, that's what they mean there. So how is it possible to see this view? Says Mark over on Facebook. You're talking about the actual view from the second stage. Those are basically wireless video transmissions from the wireless telemetry and video from the rocket. Oh, they're using Everyday Astronauts music, huh? A ticker tape parade. That's pretty cool. I can't play it. I don't have the rights to it, but I turned it up just in my own headphones so that I could hear it. That's kind of cool. Let's see. Will it be visible from Europe? Probably not. I doubt that you'll actually be able to see it. Maybe. Oh, here you go. One of my moderators just sent me an updated view. Oh, there we go. Thank you. There's the updated view from Flight Club. Thanks for that. I don't know why it didn't come up when I pulled it up, but there you go. So there's the 45 degree inclination. So you've got, basically you're hitting max 45 degree latitude here, minimum 45 degrees south right there. That's your inclination. Let's see what else we have. What do you think of extra legs on Starship SN11? I think they need different legs on Starship SN11. It means I'm still not super confident about the legs on Starship in general. I'm kind of curious how SN11 is going to hold up, but not super confident about those. But really goes up pretty fast. Yeah, pretty small rocket, super powerful engines. It comes off the launch pad in a hurry. Kind of awesome. Does the first stage return to Earth like SpaceX Falcon 9? It comes back to Earth, just not in one piece. They're not quite there yet. They will get there. They're going to catch it with a parachute. They're going to parachute it, use a helicopter to snatch the parachute out of the air before it even touches the ground. So they're going to snatch it out of midair and then set it down with a helicopter. It'd be kind of cool, but they're not there yet. They've done a couple of tests with it, and we'll see that in a future launch. I don't think they've told us exactly what their plans are on when that's going to be happening. So here, we'll go back to the live view from Rocket Lab, exactly where it is. Let's see, Jerome became a channel member. Thanks, Jerome Nell, appreciate your support there. Adam Farmer, again, the wife's going to get in trouble. You're going to get you in trouble there. Says, last one, can you tell Lindsay her man loves her? Okay, well, I'm hoping that's the wife that's you said was going to get you in trouble for sending over so many super chats. If that is, don't get mad at him, Lindsay. It's for a good cause. Doesn't Electron always seem to have a lot of movement? It's the type of guidance system they use. I don't know about the actual guidance system, but it does usually seems like a lot of movement. It could also be because it's a much smaller rocket, so the movements are easier to see and decipher. Like little movements are easier to see on camera. I don't know if that's a factor of the actual guidance system itself. Very tricky about air catching. Yes, for sure. Why don't we take a look? Let's play this here in the meantime while we're waiting here. So, because they had talked about it so much about the actual Neutron rocket. So we've talked a lot about Electron, which is their small launch vehicle, which they said that they were never going to go bigger than this. They were going to do a small launch vehicle, and you can see that's Peter Beck, the CEO. Here's the actual Electron, some simulation animations of the actual Electron. Look at how small it is. Like, that's a person, like, crouched on the inside of the rocket itself. Like, it's a pretty small rocket. Like, you can stand next to it and just put your hand on top of it. It's not a very huge rocket. I wanted to see if they're going to show... Yeah, so they'll probably show it in a minute, but yeah, the rocket body, like especially the width of it. What's the actual width of the Electron? Somebody know the actual diameter of the Electron off the top of their head? I don't know it off the top of my head. Electron. The diameter of the Electron is 1.2 meters, 3 feet 11 inches. Not a huge diameter there. So the Neutron is going to be much bigger, and I don't know if we actually have dimensions for that either. Let's see, do we have dimensions for the Neutron? Rocket Lab Neutron. I don't have dimensions to it, but it is going to take 8,000 kilograms or 17,600 pounds to low Earth orbit. So much bigger rocket compared to like the Electron, which only takes about 200 to 300 kilograms. I think the version they're on right now will take 300 kilograms to low Earth orbit. So you're going from 300 to 8,000. Huge difference. So what they got on screen here now, these are the first stage reuse videos that they have here. So you've got a camera right there from the first stage. You see it parachuting down. They landed it softly in the water during some of their tests just to see if they could survive actually bringing the first stage back. So they have done that. They haven't done the actual helicopter catch on a real mission yet, but they will do that. They've done the helicopter catch in tests, just not on a real mission. So here you go. Here's Peter Beck. You can see him walking next to all the Electrons there, like, and how small they are compared to him. When is their first launch from Wallops? I want to say, isn't it this year? When is their first launch from Wallops? First one from Wallops is, June of this, April of this year is the first one scheduled. I knew it was, I I thought the June one was going to be first, but we got one scheduled for April coming up. We'll see. We'll see what the timeline is on that. Kind of odd that the launch pad is right next to a nature reserve. I mean, it's a gorgeous launch site right down there. So this is Peter Beck, like literally eating his hat, because he said a long time ago that that they would never get into that they would never move beyond Electron. Really, they would never get into reuse. They'd never get into big vehicles. And he said, if we do, I'll eat my hat. And that's what he's doing now. Is this the hat eating video? Yes, it is. And he's sitting inside the payload fairing for the Neutron rocket. Like, that is a much, much bigger payload fairing. So remember the other one, only 1.2 meters, 3 feet 11 inches in diameter. This one, much, much larger. You can see how much more you could fit in there. 8,000 kilograms to low Earth orbit. Rocket Lab is almost at a monthly launch. Rocket Lab almost at a monthly launch goal. The goal is weekly. Okay. Can you send the link for the Wallops April schedule? There's a bunch of services you can use to look up rocket launch schedules. You can look at... let's see. Let me get this off the screen here. You could use Next Spaceflight. You can use Space Launch Now. You can use... What are some of the other ones I've used? RocketLaunch.live. For SpaceX specific ones, there's like SpaceX Go, SpaceX Now, one called SpaceX. But I primarily use Space Launch Now, Next Space Flight, and maybe RocketLaunch.live. There's a bunch of them though that you can actually get launch schedules. Can we see the battery hot swap again? Sure, yeah, we could take a look at that here in just a second. We should probably replay it anyways, because we got about half an hour before the actual deployment itself. So let's back it up. Let's see, where's our... Because I just want to see that, that ignition again. That ignition is... That's where it's at. Let's get our replay text on there. Oh, we're going to have to move that replay text because that is not in a great spot. Let's move it over here, over there. Here. Let's put it there. Perfect. Spaceflight Now.
The deluge is activated.
Yep, they have a launch schedule as well. That's a good one. What are the circles on the map? Well, we're going to have to go back because I don't recall seeing circles. Oh, we'll go back after the replay. I'll take a look at those.
All
right, here we go.
9,
Here's your headphone
8,
warning.
7, 6, 5.
Super powerful.
4, 3.
Ready?
2.
Love that sound. It's so awesome. It's just that huge hit on the actual on the actual launch itself. Like that is fantastic. Let's see what else we've got. While we'll watch in the replay, we're gonna go all the way to the battery, at least the battery hot swap. what fuel does the rocket run on? So this is RP1, rocket grade kerosene, and liquid oxygen. So the white sections of the rocket, we gotta just back it up. Watch that again. But the white sections of the rocket, they're actually, like I mentioned it before launch, the rocket is completely black. There are no white sections of the rocket. The white is ice forming on the outside of the liquid oxygen tank. So you can really see where the liquid oxygen is, where the rocket grade kerosene is. And what's unique about Rocket Lab is they use an electric pump to feed the fuel and the propellant into the combustion chamber.
6, 5.
Here it is again.
4, 3, 2.
I just love that. So awesome. Oh, how did Peter Beck get on the webcast? I forgot they were going to bring Peter Beck on. Is he on now? He is on now. We should listen into this.
Been a fantastic vehicle to really pathfind a lot of constellations for our customers.
Except they're playing Tim's music in the background. Tim, don't copyright strike me.
Thanks very much for getting our first one in orbit, but actually now we've got a whole bunch of them we need to get there. So it became really
we got to get them to turn the music off.
Really, a massive need in the marketplace for, for a vehicle specifically built for launching, mega constellations and constellations.
So you've talked about Neutron as a constellation builder, but what makes it ideal for that?
Yeah, well, I mean, it's right-sized. So, if you look at all the constellations that are in development in various forms, they all fall around a similar kind of mass class. And that 8 tons to orbit is really the ideal mass class, for building mega constellations. But not just mega constellations. In fact, if you look back through history, the average payload, mass lifted by all launch vehicles in all of history is between sort of 4 and 5 tons. So we think this is the right time to bring a vehicle that's right-sized to the market.
Cool. And what can you tell us about Neutron's engines?
Not a lot. It's a secret. No.
The secret.
I mean, there's areas that we're innovating and there's areas that we're not innovating. The engines, engines always deserve their own name, so they they certainly deserve their own limelight as well. So we'll make a little bit more announcement about engines in the appropriate time.
It'll be fun brainstorming some new names for those engines, I'm sure.
Oh, it's already named.
Have you? So tell me why you've selected Wallops as the launch site for Neutron.
Yeah, so Wallops is actually it's a fantastic mid-inclination site, and mid-inclination is really, really important for the majority of launch. We're able to leverage Pad 0A and the wonderful team there at Virginia and Wallops Island. Obviously we have the home of Electron there, so it made perfect sense to also put Neutron there as well. And one of the interesting things that if you start to look at launch vehicle design, you find a lot of launch vehicles kind of asymptote around that 3.9 meter diameter, and that 3.9 meter diameter is really a function of the lowest bridge between California and Florida. So we didn't want to use that as a design constraint for Neutron. So
makes sense.
Yeah, so we were looking for a launch site that we could also manufacture near as well.
Cool. And what is the biggest hurdle for you at the moment for Neutron's development?
Well, the biggest hurdle is for Rocket Lab is always talent. So I don't want to turn this into a shameless talent plug, but I mean, in all honesty, that has always been our throttle, is how quickly we can onboard people. The bar is high, and we're unashamedable that the bar is incredibly high at the company. But that always is our throttle in developing any of Rocket Lab's programs.
There's a few hundred jobs expected to be created for this one, isn't there?
Yeah, absolutely. Yeah. Both in Virginia and New Zealand, and in fact, in every one of our locations, I think that is our throttle.
Cool. And how is the hat? Do you expect to be eating any more anytime soon?
Well, that's why I made sure that we talked about human spaceflight and all of the things that we could possibly do in the future in one hit, because that hat was just not tasty. And as you know, Muriel, it took 2 takes, so there was actually 2 hats consumed in the making of that video. So not looking for that again.
Also, Neutron's capabilities, it's going to be reusable, isn't it?
Yeah, so that's probably the biggest fundamental difference between Electron and Neutron. So Electron was all about how do we make the most manufacturable rocket. Neutron is how do we make the most reusable rocket. There's a bunch of things about, especially the first stage, that as we announce a little bit more about the program, people will be, I think, quite surprised with some of the innovation that's in that first stage, because it really is, it really is about how do we make the most reusable, not serviceable, the most reusable launch vehicle in the world.
And speaking of recovery, can you tell us anything more about when we'll next see another Electron under a parachute?
Yeah, not too many missions away actually. So I was down sitting inside the stage there earlier in the week, and it's looking super good. So parachute was about to be packed into the stage, and all of the little thrusters and everything were on it. So it's all looking very good. And the next recovery mission is with a significantly upgraded heat shield. So the previous recovery missions have been basically, with upgraded block upgrade of stage 1 with reaction control systems and guidance systems and things like that. But we never really addressed the handling the thermal loads that we expected, because there was kind of no point, because unless you can control the entry of the stage, it's kind of irrelevant. So this one has a much more significantly upgraded heat shield, and so we're expecting much better performance and hopefully much better condition of the stage when we go and pick it back up.
How exciting. Any helicopters with this one? Will you be piloting a helicopter?
No, I'm nowhere near good enough to I'm kidding myself to think that I was a good enough pilot to catch one. But no helicopters in this mission. Basically, we're going to splash them down in the ocean until such a point as actually the stage is what we would consider completely reusable. At that point, we'll bring in that extra element of logistics with helicopters.
Very nice. Hey, thank you, Peter, so much for joining me here. It's such an exciting time to be part of the team, and I personally can't wait to be front row and centre to watch Neutron launch from Virginia.
Yep, no, it'll be great. Thanks very much.
Now, back to the mission at hand, of course. We have another 40 minutes or so to go until the first payload deployment, for they go up so fast. This coasting graphic will keep us on track for where above the world is the kick stage, and we'll be back on your screens as we gear up for that first deployment, so see you shortly.
All right, so hopefully Tim doesn't copyright strike me for playing his music there, but that was they're playing Tim Dodd, the Everyday Astronaut's music in the background of Rocket Lab, but I wanted to listen in to hear some of the things that Peter Beck was saying. Especially, I was hoping maybe he would disclose that he would disclose what the next mission was that we were going to see reusability. Sounds like it's coming up soon, but didn't give us an actual finite mission number there. All right, well, since we've got a bunch of time, I figure we could probably even simulate some of this Electron stuff and maybe get a little Kerbal action in. We can play around with the Electron. I think I have an Electron in Kerbal. If not, we'll build one. Let's see. Tim said it was fine to use this music with credit. Well, I haven't asked him personally. Hopefully he's all right with it, but certainly I will give him credit and put a link in the description below to his channel. Tim is a pretty good guy. He's actually super generous about all things space, so it wouldn't surprise me if he said something like that. But obviously, I would probably want to verify that. All right, well, we've got like 40, I think it's less than 40 minutes. So the kick stage ignition is going to be at the 1 hour mark. So we're at about 30 minutes to the next kick stage ignition. And then, I don't know, are they going to stay live through the whole thing? Because that could be a long time. That's because I've got the actual kick stage cutoff and deployment happening at 1 hour and 49 minutes, which would be like an hour and 20 minutes from now. So maybe in the meantime, we'll just get some Kerbal action going. Instead of just sitting here and staring at an animation, we can play Let's Watch Tori Crash Rockets. Oh, people talking about the circles? Imagine the circles are communication stations. Where are you seeing? You're talking about like these little dots? This is the this is the path that the rocket is going to take. Oh, maybe these red circles what you're talking about. Yeah, I would guess. I don't know if they've ever told us what that is, but based on where they're located, I would also probably concur that those are likely tracking stations. Because right now we don't have a video feed. We lost the video feed right about down here. You can see it gets outside of that radius here of the circle there. So you're probably onto whoever said that, Lewis Massey. I bet you're right. I bet those are indeed tracking stations. Remember to pack a parachute. Everybody getting excited for the Kerbal. Tori, get your rocket landing practice in. Probably should. Gonna need a lot more practice at that. Ground communication station, says Red Scorpion. Yes, and I saw. We got. I should probably back it up a little bit before too many people go away, because I saw a couple of super chats come in, like Draven Motkova said those are super views. It was pretty awesome. Like this view back here that we saw. Not this one. Right here. Look at that one right there. That's pretty awesome. I love that view. I started saying this during the broadcast. I want like an HD, or not HD, like high resolution image of this that I could just hang on my wall. Then we also said, we said we were going to show battery hot swap again here too. Let's fast forward to that a bit. Oh, we missed it because that's at, was that 548? So that's 542 right there. Oh, it's loading. Oh, now I broke it. Doesn't like me now. All right, we'll play it from there. Run and hide yourselves. Tori's gonna do some Kerbal. Yeah, why not? Who else did I see? Charles Mackienen. Charles M. Sorry, Charles. Became a member of the channel. Thanks, Charles. Robert Yanisek, doesn't the Electron always seem to be doing a lot of movies? Staying on target, is it the type of guidance? Oh, I think I read that question already. But thanks, Robert. Thanks for the super chat. Yeah, I don't know if it's about the guidance. I just seem to think that it's because it's a smaller launch vehicle. What's going on with our feed here? We can't watch the battery hot swap. It's secret. Here it is. Here's battery hot swap. 3, 2, 1, go. Look at that. Was a pretty cool view. I don't know if we've actually seen it that close up before. I missed the last launch, so maybe they showed it on the last one, but you can see the battery right here above my head. Just pops off and away it goes, and the other one's on the other side. That was kind of cool. All right, play Kerbal. Yeah, I'm waiting for Kerbal to load. Kerbal takes a while to load on my machine. Oh, there it is. Okay. Oh, what happened? Oh, no. Oh, no. Well... I'm saying oh no because there's an option I have to enable. I must have updated Kerbal. Well, maybe it's okay. If I like click off of the... Yeah, see... That's annoying. If I click off of the program, it hides it. And I have to like make it full screen window. That's alright. That's alright. We'll just mess with it. Well, what I wanted to do, this is why I was clicking off, is because we needed to get our pump-up jams for Kerbal. All right. Do I have an Electron in Kerbal? Let me see. I don't think I have. Now that I'm thinking of it, we got starships, we got Falcon 9s. We got, I think this is a Falcon 1, which is kind of like an Electron, I guess, except different engines, but I don't think I have an Electron. Do I? Well, what should we do? Should we build? I'll give you guys the options. We could fly a Starship. We could try to build an Electron. We could fly a Falcon 9. Falcon 9 might be kind of fun because then we could try to land something. We could fly Falcon Heavy. There's Falcon Heavy. What is your thoughts? You tell me what you think we should do here today. Electron, Starship, Falcon 9. The first three responses are all different. Single stage to orbit, maybe? You think I can do single stage to orbit? That might be tough for me, but... Falcon Heavy, says Virginia. Single stage to orbit, Falcon Heavy, Falcon Heavy. I'm seeing a lot of Falcon Heavies. It'd be weird to do a Falcon Heavy during a Rocket Lab live stream. Go for the plane with the SRBs again. That was fun. What am I seeing? Catch me up, says Jamie. All right, so what you're seeing, we had a successful Electron launch. We're in a coast phase right now for quite a while. That's where the Electron is located, right here. In a 45-degree inclination, long coast phase. And in the meantime, since we got nothing going on, we're gonna try to crash some rockets. We're trying to decide what rockets we're gonna crash. Build the Lego Saturn V. I'm gonna do I got a whole separate live stream we're gonna do for the Lego Saturn V. That's gonna take me like 8 hours. I'm not gonna do that today. Put Starship on Falcon Heavy. Well, that could be interesting. Falcon Heavy, I've never seen a live Falcon Heavy launch, real or Kerbal. All right. The Wright brothers' first plane. Starship Super Heavy. Plane launch of Falcon Heavy. Oh, these are all such great ideas. I feel like... I don't know what I feel like. I'm currently writing some Starship belly flop and landing code. Interesting. Starship on Falcon Heavy. Oh, man. I don't think Falcon Heavy could lift Starship. Well, all right, we'll try it. You want to try it? We'll try it. All right, I have to set that aside. I'd have to... Oh, wait. We'd have to merge in... No, cancel. Open. I see, don't save. We want... let's go here. We'll merge that in. Wait, I don't know how to do this. I might have to merge it the other way. Let's... Okay, don't save. Open Starship. Okay. Uh-huh. Okay, here's Starship. This is supposed to be like SN11. This is like the early prototype Starship, not the finished model. Here, get this out of the way. Okay, don't save. Let's do Falcon Heavy. We'll merge this in. And we'll put it... Yeah, how is that gonna work? There's no... What? What? No. Here, get this out of here. Wait, no. This right here. Hold on. What is happening? Oh, no, now I did it. Now I ruined it. Ow. I don't know if I can even... I don't even think I can do this. This is gonna be stupid. Alright. Oh, wait. You go up here. Okay, move it up. Open. Don't save. Falcon Heavy. Merge. How do I... Okay, somehow we need to attach these together. I want to put... Let's see. You go here. Go on big rocket. Go on slightly less big rocket. I don't know if I can merge these two together because I can't take the... Okay, wait a minute. I got an idea. Hold on. Hold on. I'm gonna open this. I got an idea. We're gonna open this thing. Get rid of that. Do we want the second stage? Yeah, what the heck? We'll keep the second. No, I don't know. No, I don't think we want the second stage. Hey, let's get... Okay, get that out of here. Get that out of here. We don't want that. Let's put this like that. We probably don't even want the transporter erector. Get rid of that. We don't need that either. Okay. We're gonna save this as Falcon Heavy Starship booster. But yeah, sure. Save. Okay, open. Open. This is not gonna go well. I can already tell. Open the Starship and put it on top of on here. Go no. Can't do it. I'm excited to see this if it works. There's no way this is gonna work. It's gonna be a disaster. Okay, Starship, open, don't save. Let's get our new one here. That one. Merge. And oh no. Wait, what am I gonna attach it to? Just attach it to the engine bells? That's not gonna work. Oh, why not? What the heck? Alright. Wait, we're gonna need like a... we need like a fairing or not a fair, an interstage of some sort. What? Oh goodness. Probe core? No. I need an interstage. Like a coupling of some sort. Coupling. BFR decoupler. Yeah, okay. Like that. That's huge. Why is it so big? That's a smaller one. Inline no, we don't want that. This one? Oh, that's tiny. Hold on, this is gonna be ridiculous. Almost. Let's use this one. That was probably the closest one we had. Okay. Okay. Oh. Okay. Wait, nothing's attached. What if I launch it like this, with nothing attached? There's no way that's gonna work. Why do you guys make me do this? Okay. Just launch it already. Let the chaos commence. Remove the second stage using shift click. Shift click. Oh, but I don't know if I want to do that. I just need... Let's see. We probably don't need that. Let's get rid of that. Let's put... a Falcon 9 decoupler. It's going to be off-centered. What if I do this? Yeah, oh, of course. That's gonna... That's... yeah. Yep. That's it. Alright, watch this. We need some structural supports. Where's our structural supports? Structural. There it is. We need, maybe like struts. Lots of struts. That's what we need. Strut. Nope, it's not gonna work. Can I do struts on the inside? There's no way this is gonna hold together. Oh, it worked. One strut, that ought to hold it. Let's put one over here. Like that. Yeah, oh, this is not... this is not gonna be good. Strut here, like this. Oh, there we go, alright. Strut. We need lots of struts. So there's no way this is gonna hold together without some struts. Strut your stuff. Here it comes. All right. Yeah, like that. Yeah. We're gonna hold this. This thing is gonna be held together with duct tape and super glue. Is there any chance that this survives more than 10 feet off the launch pad? I have a feeling the answer to that is absolutely not. This will not end well. I have a feeling you're correct. All right, but we have lots of struts, so we got that going for us. Here, let's add some struts to, like, the boosters maybe or something to hold this guy in place. I don't know what we're doing. Yeah, that's totally it. Okay, yeah, perfect. It's looks, yeah, exactly like what a rocket manufacturer would build. Okay, we got those up there. Let's check our staging. Got those. We got... So, let's just put all those in the same stage. We're gonna call this the, Never Gonna Happen 3000. Perfect! Launch it! Here we go. I gotta fix this squeaking chair. This whole time. Hear this thing? Of course now. The Abomination. Oh, that would have been a good one. I just got on and I hate to ask, but do we know when it's launching? Oh, yeah, so you missed the actual launch part. The launch has happened. Oh, we should listen.
Payload deployment, our operators and mission control will issue a command to transition the kick stage into spacecraft mode and begin our secondary mission objective to test out new systems on our own satellite. This Photon will build flight heritage across its subsystems for our capstone mission to the moon for NASA this year, as well as our private mission to Venus in 2023. We've got some new and exciting technology to demonstrate on Photon this time, including deep space radio capability, sun sensors and star trackers, and an upgraded reaction control system for precision pointing in space. We're coming up to the release of the first satellite from Electron shortly, so let's listen in for the calls from mission control.
Now I don't want to go back, because so the press kit didn't have or maybe it was just final satellite that they said in the press kit. Where's the press kit? So in the press kit, they had only said, oh yeah, it's just final payload deployed at 1 hour and 49 minutes. Oh, I missed this one right here. First 5 payloads deployed. I missed that when creating my events list. 54:56. Should have added that in. So I guess we are coming up on a satellite deployment. Let's add that in real quick. 54:56. Right? Is that what I said? Can't see my button. I have to stand up to see the button that I have to push. Okay. We got Tim's music playing again. All right, so we've got first 5 payloads, 5 of 7, which is pretty much most of the payloads happening here in just a couple minutes. So maybe we'll wait on the Abomination, the Apocalypse, the what were some of the other names that people were giving for our awful rocket here. I will say, before we get to, it's standing on the launch pad, which is way more than I expected. Like, what in the world how is that even standing? That's ridiculous. That should not be happening. Franken Heavy Starship. Like, I mean, it's standing. Which is not believable. Oh, why is that happening? Alright, so they're still just playing Tim's music here. Looks like I'm 10 during our got a couple seconds off on my timeline here, so we're like, oops. I'm 1 minute off here. There's our timeline now. So we should be coming up on that satellite deployment any second now. Probably not going to actually see it, but we should get some sort of confirmation at least.
Now what you're seeing on your screen is a simulation of payload deployment. We will confirm all payload deployments on our social media channels shortly. Great, and there is the third payload deployed from Electron. This one is tiny, it's about the size of a bagel. But next up is the small sat for SMDC. This one is the size of a loaf of bread and is being deployed by Rocket Lab's Maxwell CubeSat dispenser.
He said it was the size of a bagel. Now I'm hungry. I haven't had dinner yet. It's dinner time here where I am. There we go. Another one.
And as you can see in the simulation, the payload from the U.S. Army's SMDC has been deployed to its 550-kilometer low Earth orbit. The final payload at this orbit is up next, and it's the Myriota 7 satellite.
Of the Myriota satellite.
Should be the last one here. And then I don't know, they might be cutting it off after this, the broadcast.
And there it goes. That's the 5th satellite on this mission deployed. The Myriota has been deployed to its orbit as planned.
All right, that's all 5 they're doing at this orbit.
Congratulations to all of our mission partners so far, and let me be the first to welcome you to your new home in orbit above the Earth. We have one final payload to deploy on this mission, the Gen 2 spacecraft from BlackSky Global. But as we've mentioned before, we have to drop the kick stage to a lower orbit first.
We'll do this with a second relight of the Curie engine to change the kick stage's altitude, and 40 minutes or so after that event, Curie will be ignited for a third time to circularize its orbit around the planet at 450 kilometers above us. Then soon after that, kick stage will transition to photon mode and remain in that orbit to test out some of the spacecraft's new technologies.
We won't be live for confirmation of payload deployment, but it should look something like this.
So it sounds like they're going to cut off here in just a second.
Keep an eye out on our social media channels for verification of final payload deployment and the transition to Photon later today.
Now, before we close out the webcast, I want to remind you that we are still actively recruiting for over 90 roles across the Rocket Lab team. So if you've ever wanted a career in space, there is no better time than now. Head to rocketlabusa.com for more information. And a huge congratulations to the entire Rocket Lab team on reaching this awesome milestone of over 100 satellites on orbit. And a huge thank you, of course, to our mission partners for choosing Electron to fly on your mission. And a final thanks to you for joining us for this launch. I'm Muriel Baker.
And I'm Scott Moeller. This is Rocket Lab Mission Control, signing off.
All right. Well, they're going to end it there. So there is one final payload that they have not yet deployed, but they're not going to show us that. That would still not be for another almost hour. It's like 50 minutes from now. But that's all right. We need to launch Franken Heavy, whatever the abomination that we built. See what we can do with it. Damiana asked, was that a simulation or was that actual footage? That was a simulation of payload deployment, so that was not actual footage of payload deployment. But that was just that was a simulation. And speaking of simulation, we're now going to we're going to give this a shot here in Kerbal. And let's see if this thing will fly. Do you think it will fly? Where would they get the camera to film it? I mean, you could put cameras on the kick stage. The problem is, like, they don't have a ton of different coverage areas for ground stations to actually send that video feed back. So you could get camera footage on there. I mean, that's how we see, like, Starlink deployed and, you know, other satellites deployed from Falcon 9 or things like that. But all those cameras, they're primarily engineering cameras, and so they're not really there for our entertainment purposes. I mean, yes, they're nice and entertaining, but their primary purpose is engineering. So, cue the epic music. Should we restart my epic music? I gotta fix my Kerbal for next time, so it doesn't defocus the window. All right. All right, we got this. Going to orbit, you think? I see Robert says he sees a RUD coming. This is Star Falcon Heavy. Falcon Heavy Star. Falcon Star Heavy. I don't know what we're calling it. The abomination. Will it fly? In 3, 2, 1, go! What? No way! Get out of here! There's no way! What? It's flying! Get out of here with that! This is ridiculous. Not only is it flying, it's accelerating. I didn't even think it was gonna get off the pad. What? Oh, we're going to orbit. We're going to orbit. I mean, we're slowly ascending. But she is flying. Holy smoke. It's not accelerating very quickly. You need to make a clip of this and then tweet Elon. Where's my marker? There we go. Put in a marker so I can go back and find it later. You gotta land the starship. Alright, well, I'm just concerned. I'm gonna start this gravity turn. And... oh, wrong way! Alright, well, I guess we're going this direction. Uh-oh. Uh-oh. This was not... I did not want to go retrograde, but... we're going retrograde, because I don't want to tempt fate. Get out of here. We're actually... It's holding it together. Oh my goodness. It's fighting me a little bit, but it's relatively stable, which is ridiculous. Oh, it's fighting me. Oh, but it's going. It's going. We're at 32 kilometers. And we're going retrograde for who knows what reason. Look at this, 40 kilometers. We're gonna make it to space. I think space and Kerbal is on. Uh-oh, all right. Stage sep. Oh, we gotta do both stage seps. Uh-oh, now how do I... Yeah. Oh, yeah! Get out of here. Oh, I have no vacuum engines, though. I didn't expect to actually make it this far. I have no vacuum engines. Look at, we made it to space. 70 kilometers in Kerbal that's space. Get out of town. That is just... Oh, look at, we're gonna make it. Oh, look at all you doubters. Look at this. Where'd it go? Oh, there it is. I'm like zoomed way out. Where's my Kerbal engineer? Need my HUD. Get out of here. Look at this. We're in orbit. We're in a circular orbit. It made it. What? All right, now can we bring it back in? What's on board? I don't know. I can't believe that even launched. All right. So, and we're in retrograde orbit. Not convinced yet. Now land it. Okay. I have no fuel left. Okay, let's try to land it. We're gonna try to land it back at the Space Center. You think we could do that? I doubt it. So to do that, I gotta go like, oh, I don't know, here? Let's warp up to there. 5 and 6 are flap deploy. All right, good to know. But we'll test that. Let's see. 5. Yeah, 5 works. 6. Oh, wait, that's 4. 6. 6. Yeah, 5 and 6. Look at, she did the little flapperation. Operation flapperation. Okay. All right, can we land it? I have no fuel left for this. I might have to cheat and go infinite fuel. Let's see. Bring it in a little. Like that, maybe? Or should I do more? What do you think? Let's bring it in a little more. That's enough. All right. It's like a train wreck. I can't look away. I know, right? Okay. All right. So there. Now we did the deorbitation maneuver. It's gonna deorberate. Yep, exactly. It's gonna deorberate. We gotta go radial out. Here's my squeaky chair again. All right, we're radial out. We have no heat shield. No heat tile. This is SN9. It's only designed for suborbital flights. But, okay, cool. I think we're facing the wrong way. We're gonna be facing this way. Right? Elon should hire you. Let's wait until she lands first. Do I even have landing legs? Oh, we do have landing legs. Look at that. How about that? They're even the... Oh, this must have updated, because I don't think I had this before. we're gonna explode on re-entry. I have no, yeah, we got no heat shielding. I don't know how we're gonna survive re-entry, but let's see. Fast forward. Fast forward. Fast forward. All right, here comes entry interface. Save it first. Yeah, which one's save? F5, F9. Which is quick save? F5 or F9? I can't remember. F5, I think. Quick saving. There we go. All right. Commence operation flaperation. Coming up on entry interface. At 70 kilometers. There's 72, 71. Okay, what's our map look like? We're a little long. Okay. Maybe we can retrograde the engines real quick. Oh. Oh, uh-oh. Uh-oh, what's happening? Oh, we might be heating. Oh, uh-oh. Is that turning red? Does that look like it's turning red? What's happening? I wanted to go retrograde and then burn the engines. Try to bring us in so we actually land on land. At least land on land. Alright, let's go radial out. Where's my Kerbal engineer? So at least I can get landing. Show Kerbal engineer. So at least I have a chance of doing some sort of... Oh, here we go. Entry heating. Slow it down. Here we go. No heat shields. Stainless steel is supposed to be okay with heat. Remember, SpaceX was originally going to they were originally going to use some of the propellant and like just have it weep out of the windward side there to cool the face of it. All right, suicide burn is a 1-minute burn. Depends on if we can scrub off some of this heat, which I hope we do. Here we go. We're coming in hot. Oh, boy. Oh, now she's getting angry. Now she's getting angry. We're still going 1,600 meters per second. This does not seem like it's gonna work. We're dropping speed quickly, though. We might have just gone a little bit too long on the... Maybe we just went too long on the re-entry. There we go. We survived the heating. This is fine. This is fine. Oh, look at... Oh! 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 Wait! Wait, I need... Oh! Oh, here we go. Now we're going almost straight down. Operation Flaperation! Get out of town! It's working! It's working! Look at this! We're slowing down! Oh, no. This is ridiculous. This is ridiculous. What do we need? What's our suicide burn is still... We're okay. We're okay. We're all right. Flip. No, not yet. Not yet. We don't need the flip yet. We're slow. Look how fast. Look how much we're slowing down. 120 meters per second. I haven't even fired the engines yet. This is like the real deal. There's our landing spot. You can see our target on the ground right here. Oh, if we pull this off, it's going to be ridiculous. All right, our speed has stopped slowing down. I think we're at terminal velocity almost. Suicide burn. We still got time. We still got time. We're at 4 kilometers. And that's sea level, so what's our... Oh, we got some horizontal movement. That's not good. We got horizontal movement. 77 meters per second. There's our terminal velocity. Look at, now we're flying. We're flying. We're not even falling, really. Gear down. Oh, she bounced. Uh-oh. Uh-oh. Oh, no. Oh, no. Ah. Oh. Well, she kind of survived. She bounced, just like SN10. Oh, man. Well, that was fun. SN9 meets SN10. That, like, I'm not gonna lie. That went way better than I expected. There is no way any of you guys thought that that was gonna make it more than 10 feet off the ground. Oh, just like real life. And it didn't completely explode, just the top half. We lost the top half. Ah. And you did it with Falcon. Yeah, right? That was nuts. There's no... Yep, all right. Well, I mean, I think that's pretty good. Come on, give me some credit. That was the... What did we call that? The Starship Falcon Heavy combo? Star Heavy? I don't even know. We got to come up with a name of that. The boing, somebody said. Click the button besides altitude, it changes from above water to above land. Oh, really? If I go like this, it does... Oh. Wow, all the years I've been playing Kerbal, I didn't know you could do that. Wow, who was that? Living with... Oh, I know living with spina bifida. That's, I didn't know that was an option. I've always used Kerbal Engineer, but I couldn't find it. I was trying to find... I don't remember which... Oh, I can't do it right now because this is open. If I go to Kerbal Engineer, there we go, surface. It'll tell me altitude, terrain. I'm at 252 centimeters right now. All right, well, and there's a mod that'll automatically do that for me. Well, that was fun. All right, I think I'm going to end it right there on that. We'll do some more of that at some point. That was exciting. I always like crashing rockets. Heavy Star. Yep, I like that one. That's a good contender. Falcon Star Heavy. What did we learn? No need for super... This is from Termax HD. What did we learn today? There is absolutely no need for the super heavy booster. Just strap a Falcon Heavy to it. Don't forget, lots of struts. Lots and lots of struts. That is the key. So you need to have lots of struts if you're going to do Falcon Heavy and Starship. Starcon Heavy, Franken Heavy. I like Franken Heavy, to be honest. That's Carl Johnson. What... Just wait a few minutes, it'll still explode. Yeah, we have to stay live for 8 minutes to see if we're gonna lose it. We're going to Mars next year. Starcon Heavy, Super Falcon Heavy, Super Falcon Starship maybe or something. We need Elon to tweet review this. Falcon Sloppy. Yeah, it's not good. Not good. Whatever we just did. Don't try this at home, kids. It's just... This is just not how you engineer things. This is a poor example I'm setting for people. I don't know, but it was a lot of fun. Next, put a Tesla Roadster on it. We should do that. We'll do some more. We'll do some more another day. Do you think SN11 will launch tomorrow? I think we're looking at Wednesday for SN11. I think that's what I'm expecting is Wednesday. I have not seen any indication that tomorrow would be the day, so I'm thinking Wednesday is the day that they're going to give it a shot. So, all right. Well, that's going to do it for me. We had some fun. Rocket Lab successfully put their payloads and their satellites into orbit today. And we had some fun crashing whatever that was that we built today. No TFRs or road closures for the 23rd. Yeah, I saw TFR. I don't know if they retracted it, but definitely there were no road closures. And Mary, Boca Chica gal down in Boca Chica, has not gotten an alert that I know of so far, an evacuation alert. So I don't think we got a Starship tomorrow. I think maybe Wednesday might be the day. So, all right, that's going to do it for me, guys. Consider joining our Discord if you haven't already. And I'll see you guys probably. The next thing will be Starship SN11. Hopefully. Fingers crossed that'll be soon. All right. Thanks, everybody. My name's Tori. This is Overlook Horizon. We'll see you next time. Goodbye.